Welcome to the Health Edge, translating the science of self-care. I am Mark Pettis with my friend and colleague, John Bagnulo. John, good morning, my friend.
Good morning, Mark. It's great to see you, buddy.
Great to see you, as always. We've been looking at some research, John, on lithium and the sort of growing interest in lithium as a supplement, and a lot of what is being looked at now to offer potential protection in the brain specifically. Lithium has been around for many, many, many years. And I think most people know lithium through its effectiveness in the treatment of bipolar disease. And in 2026, lithium continues to be one of the most time-tested and effective interventions for bipolar disease. And it's been a huge quality of life benefit for so many dealing with that. But here, when you look at lithium in very small doses, nothing, a fraction of what you would use to treat bipolar disease, it has a lot of really interesting effects. And so it seemed like a timely topic as more people, I think, are hearing about the potential utilization of lithium in the aging longevity research, in the brain health research. And so we have a few recent papers, a few recent reviews that look at the mechanisms, why it is that lithium may provide benefit. And while the clinical human trials, I think, are very limited at this point in time, I think we're going to see an explosion of this. And so, that it's a good topic to review, John.
Yeah, it is. And, a few things come to mind when we discuss lithium. I'd say that it was like at least 20 years ago that I first heard you recommend lithium orthotate, I think at like 0.5 milligrams per day. And you were way ahead of the curve with this, Mark. And I think it also serves as an example of how much we don't know about the nutrients and the molecules that the body requires for optimal function. And people like Bruce Ames, who developed this triage theory where the body will substitute, in this case, like a trace mineral. We might substitute a different trace mineral in for lithium to drive a particular enzyme or to work in a particular biochemical pathway, even though it's not ideal, it's not the first choice. And I think there's some evidence that the body does that. If we don't have adequate lithium, we substitute another trace mineral in place of lithium, but things don't work quite as well. You have a little more inflammation, you're a little less effective at clearing in neurological issues that we'll get into in a moment, inflammation based, of course. So, I think there a lot of things come to mind with lithium, but I think it's something that to your point, we're gaining greater and greater insight because now we see the mechanisms for how it works for the body, the important roles it plays neurologically as more than anywhere else. And we're starting to see these kind of big picture associations with lithium concentrations in an individual's body, and then how their physiology reflects that, whether it's, again, their risk for Alzheimer's, whether it's in terms of behavioral, mood disorders. There's now a pretty big body of evidence that shows the lithium concentrations in a population's drinking water have very, very strong associations with a lot of neurodegenerative diseases in general. And it's very protective, I should say. So, it's fascinating, but I love these topics, Mark, as I know you do, because, and our listeners may or may not appreciate this like we do, but it's fascinating to see how much we don't know, right?
Yeah.
I'll leave it at that. And this isn't the only molecule. This is just the latest that we've discussed. I mean, when you look at choline and how recently choline was determined to be an essential nutrient, it just speaks volumes to the fact that we haven't figured everything out. And we're actually a long ways from figuring out what we actually need for optimal health how important soil nutrient content is for optimal health. That's a whole nother part of this topic, right? Lithium can become depleted in soils very quickly, especially the type of
Mm.
agriculture that we practice, Mark, which is, basically fertilize with what you need to produce a plant, but it's not everything that we need for our health. So anyways, it's an awesome topic, and I can't thank you enough for bringing this up today.
Absolutely. Great context there, John. So let's look at, I'm going to pull up some slides and we'll look at some of the studies today. These are more recent studies. A lot of them look at the mechanisms, and like so many things that we like to review, there's some pretty geeky
Mm.
biology and physiology here, but it's not important to understand all of that as much as it is to really have deep respect for how a very simple molecule can exert a host of biologic effects in humans, and the extent to which many of these effects seem quite positive in a molecule that's time tested and has a pretty good safety profile. And again, we're talking about very low doses here. So I will pull up those the slides that we have, John, and start with a good place to start to give people a sense of really what lithium is. I mean, we hear a lot about lithium in batteries. And, lithium is sort of a hot mineral because, batteries and generating energy, particularly portable sources of energy, are so enormously important today that people tend to hear more about it in that context, unless you know someone who's being treated for bipolar disease. So here are just a few high-level bullet points. So this is if you look at a periodic table of elements, lithium is up to the top of that table. This is 3 on the periodic table. And this atomic number, as people might recall from their painful sort of chemistry 101 days, means that the lithium has 3 protons. The atomic number speaks to the number of protons in that element. And generally the number of electrons will be equal to that. So lithium has 3 electrons, and we often talk about, John, any element that can easily donate an electron seems to have more significant antioxidant, often anti-inflammatory properties. And so lithium, just looking at this, you can see that its structure lends itself to easy donation of 1, 2, or all 3 of its electrons. And so common is that capacity, John, that lithium, when you see it in a paper or if you're just researching it, you'll see it as Li3+, which is what lithium is when it has donated all 3 of those electrons. So this is a very small, very simple molecule. And it's highly reactive. That's sort of the point I'm trying to make. It doesn't exist in its pure metallic form. Instead, it occurs as a salt. So when you give an electron, you are usually combining with another element that is the recipient of that electron, and lithium then is in its salt form. And there are 2 primary sources of lithium, and some of this was new to me, John. These continental brines, these lithium-rich groundwater found in arid salt flats. The lithium triangle referred to that rich area, 50% of the world's resources in South America, Bolivia, Chile, Argentina. And then you can also find lithium in rocks, and Australia is one of the leading producers as they extract lithium from hard rock. in nature, most of what we might consume would come from the water and from the soil. And to your point, John, we know that modern agricultural techniques very much diminish the concentration of these minerals in soil. So the quality of our soil is not as good as it once was, and therefore the quality of those nutrients in any plant that we're consuming will not be as strong either. But generally, we will get this from water, underground geothermal wells, low concentrations in drinking water. You mentioned a study, John, and I will look at this in a moment, of parts of the world that do have higher lithium in the drinking water. And I believe Australia is one of those countries where you do epidemiologically,
Mm-hmm.
compared to people who have no lithium in their drinking water, we'll see differences in the prevalence and epidemiology of mental health. And
Oh, it's amazing, Mark. It's amazing. And I looked at the studies that examine the relationship between, and this might not be the best time to go into this, if you want to wait.
oh, go, John. That's all right.
Yeah. Well, I mean, again, a lot of times these associations kind of get thrown out. People are like, yeah, but we don't, that's an association, but we're not demonstrating cause and effect. However, as you know, at times the strength of that relationship can be such that it's hard to ignore. And I think, to your point, when you look at some of the mental health parameters, suicide rates, violent crimes, it's incredible, incredible how strong and linear the relationship is between drinking water, lithium content, and the rates of whether it's a mental health disorder, a suicide rate, the incidence of violent crimes. It appears to be like a complete inverse relationship with a Pearson's correlation coefficient, again, which just describes, for our listeners, it just describes the strength of that relationship. You start to peel away other potential variables, and you start to look at how things move with higher levels of lithium and lower levels of mental health disorders. And it's really clear that there's something going on there in terms of its ability to stabilize mood, right? Provide people with a more balanced outlook on things. And I think it goes back to, at that basic chemistry level that you just went through, it just goes back to this molecule's ability to help us stabilize, right? We could look at that on a molecular level, and we could look at that on a mood outlook type level. I think we can go micro and macro with this tiny molecule. It's incredibly lightweight, right? But it just really moves the needle in terms of brain function, neurological patterns, and brain health overall.
No question. And like so many things in nature that appear to have strong epidemiologic correlation and very provocative mechanistic data to support those epidemiologic findings, you do wonder why you don't hear more about this. And again, I can't help but, lithium again is something that you find in nature that can't be patented. There's no money to be made
That's it.
at lithium
Right.
by big pharma. So the lithium that's been around for generations to treat bipolar disease, it hasn't changed, right? And it's an inexpensive, and though there are some risks, close monitoring of levels, but there's no incentive to be developing this or researching this clinically because no pharmaceutical company,
There's no profit. There's no real profit
to be made here. So
Yeah.
this would fall into the category of strong potential, very little profit motive, and therefore for the consumer, understanding this is even more important because, and again, there's very little lithium in the human body. The average human, and it's funny, John. I grew up and was trained at a time where 70 kilograms was used and is still used as the average size of the of the American adult.
It's a little outdated.
We're going to have to, yeah, it's probably closer to 85, 90 kilograms.
Yeah, I'm going to say it's
But
almost
in your
triple
average
digits. Yeah.
person, you'll see 7 milligrams of lithium. In the treatment of bipolar, often you're looking at doses between maybe 300 to 600 milligrams on the low end, up to 1,200 milligrams on the high end. So, and in supplement form, most of the studies look at very small doses. 5 milligrams would be typical.
Right.
Which is what I've been taking for some time. Lithium isn't produced by the body. So one might say that it's an essential trace nutrient. You have to get it from your environment. Most of lithium will accumulate in the brain, kidneys, and bones. Again, this is a little bit like sodium. It's a small molecule. It can access cells relatively easily. And you'll find small amounts in vegetables, and most of it, again, coming from the soils that they're grown in. Coriander leaves, tomatoes, garlic, nutmeg, cumin seeds can also be found in onions and cauliflower, rice, mushrooms.
But to your point, Mark, it's largely a function of soil concentration. So it's the same story with selenium. It's the same story with chromium. Like, we have a handful of foods that contain them on a consistent basis. When you get to lithium, you're really getting down to Brazil nuts, and that's Brazil nuts grown in Bolivia, where the soil concentrations are very high, and you're not turning that soil over and depleting it by growing one crop every year after another, right? You're harvesting Brazil nuts from trees with deep roots that are considerably older than, let's say, a plant that's grown each year and has to be cultivated from seed. So, the nuts and seeds category, I think it's important for our listeners to know it's a function of a few things. One is a lot of these nuts are grown in minerally rich soils because the trees don't do well if they don't have that. And that's why Brazil nuts are such an exceptional source of selenium. But it's only the Brazil nuts that are grown either in Bolivia or Brazil, the rainforest of Peru, because those soil concentrations are so high to begin with that there's just a massive reservoir there. But, the point you're making here is like, lithium is something that it's hard to get from food, especially conventionally grown food that's been grown in soil that has been, worked and cultivated for decades. It disappears.
Yeah, and it does make one wonder, and I'm not aware of any research looking at this, John, though there's a lot of research looking at how depletion of soil minerals very much impacts nutrient density
Oh, yeah, 100%.
of modern agriculture.
Yeah.
But when you look at sort of the epidemiology, right, John, of mental health, and over the last generation or two, we've seen huge increases in depression, bipolar disease, and cognitive challenge that we might call ADHD or post-traumatic stress. These are hyper excitable neurologic states, and one can wonder, is it possible that a complete depletion of lithium and other trace minerals that we know are essential to mental health and brain function, you can no longer rely on dietary sources, and these dietary sources tend to be plant-based, right, John? And people eat so little vegetables and nuts that one could easily hypothesize that these are systemic contributors to today what we might call epidemics of mental health disease and compromised brain health. And so we know that lithium does play a critical role in protecting brain cells, mood stabilization, as you've pointed to, John. And we'll look at some of the research addressing cognitive decline. As we said, this is an electron donor. It is a master donor with antioxidant properties. It promotes neuron growth, balances this this symphony of neurotransmitters that we know are very intricately connected. We know that inflammation is probably one of the major drivers of all chronic complex health issues. Certainly in the brain,
Yeah.
it is highly associated with all degenerative neurologic diseases. And so, again, trace amounts of lithium are linked to neuroprotection. And we know that lithium also stimulates BDNF. We talk a lot about brain-derived neurotrophic factor. It checks all the boxes in terms of what the brain would need for optimal plasticity, learning, memory. And we'll look at these mechanisms, John, but one of the major players in this story,
the glycogen synthetase,
yes, is lithium's ability to inhibit, to turn down the volume on this protein GSK3, this glucagon stimulating kinase. And kinases, one will read a lot about kinases, these family of enzymes that they will attach phosphorus, a phosphate, to other proteins that activates them. So these are regulatory mechanisms, these G proteins that sit in the cell membrane. Lithium interacts with these G proteins. The protein reconfigures its shape, which alters its function. And then you have this sequence of kinase, this sort of amplification of phosphate donation, which can unleash a whole host of intracellular biochemical pathways. And in this example, inhibiting GSK is associated with a host of beneficial effects, including perhaps interference with these tau plaques and neurofibrillary tangles, which are commonly described in people with cognitive impairment and Alzheimer's disease. We know that overstimulation of GSK promotes brain inflammation. So as we'll see, inhibiting GSK has very powerful beneficial effects. And there's some interesting research looking at lithium and bone health, fracture healing, osteoporosis, and lithium is not commonly discussed in that context. So I do think, to your point, John, we're kind of at the tip of the iceberg of our understanding of how powerful a trace mineral like this can ultimately be. This is a recent research paper published in January of this year from Molecular Neurobiology, lithium therapeutic functions, a really nice overview of many of the mechanisms, toxicity, most of which has been associated with much higher doses than what we're talking about. But they looked at really a review. And this is a nice graphic from this paper, just sort of illustrating the bioavailability and sort of the pharmacokinetics of lithium. So as we ingest it, most of it is absorbed in the small intestine. Very highly bioavailable. Again, this is a simple...
That speaks to its importance. Like that's very important, Mark, I think, for our listeners to understand. High bioavailability often speaks to the importance and the essentiality of a nutrient, right? I mean, you look at sodium and you look at potassium and how important those are and how intricately involved they are in so many body processes. They have that same bioavailability.
Exactly. They're not going to be broken down by an acidic environment in the stomach.
Right.
It peaks rapidly within a few hours, complete absorption within 6 to 8 hours. And that, gets into your bloodstream, into your tissues. And here our focus is more on the brain. So, CNS concentrations are about half of those in serum, but can increase to as much as 75 to 80%. So there's very good data to support the fact that lithium will cross the blood-brain barrier. Many molecules will not have access to that, and lithium does. And the kidneys are the way in which lithium is eliminated. Again, in low doses, almost any level of kidney function will handle lithium, but in higher doses to treat bipolar disease, for example, some people with chronic kidney disease will necessitate moderating that dose because the elimination will be impaired and you'll have a narrower therapeutic window. So lithium can easily be monitored by blood testing. So it's which is the other kind of nice attribute of lithium. You can measure blood levels, you can monitor and adapt dosing based on those levels and based on side effects and how a person is doing. But when you get to the low levels of 5 milligrams a day, most of that becomes irrelevant. And then when you just look at these sort of global effects, and again, this is a bit technical, but it speaks to the various pathways that lithium modulates. And one of the most important, and you alluded to this, John, is this sort of calming effect that lithium has. And one mechanism whereby that happens is it increases these inhibitory levels of GABA, gamma aminobutyric acid. And if you look at people that have PTSD or people dealing with depression, people dealing with psychosis, people dealing with ADD, ADHD, they often have very low GABA levels. They're in these chronic excitatory states. And, spend 2 minutes on social media and look at how quickly someone
can get there
in public can get to a place of wanting to destroy another human. You realize that you probably have the systemic of inhibitory
GABA.
Signaling.
Yeah.
Lithium has a nice effect through GABA. And we know that it also has very beneficial effects on the serotonin system, which is a bit oversimplified in its connection to depression and mood, but it's important clearly in enhancing mood, cognition. And then when you look at the more excitatory pathways, the opposite of GABA would be glutamate. Lithium inhibits these glutamate systems. So you see drops in glutamate levels.
Which is great for the mitochondria because excessive glutamate, and excessive glutamic acid are really destructive to the mitochondria. So, here, this is, I think, where the neuroprotective component comes in with respect to mitochondrial health.
Yes.
And those mitochondria, as you know, Mark, I mean, the neuron is so metabolically active. I mean, the brain collectively is one of the most metabolically active organs, largely due to mitochondrial activity. And we know that as those mitochondria become compromised, it invites all the different neurodegenerative diseases, that have that energy crisis component. So I think this is a big part of this amazing engine that we have inside our neurons, a neurological mitochondria, and how that engine needs to have everything just right. It has to have the exact right engine oil, so to speak. It has to be high octane fuel, has to have high viscosity oil because of how metabolically active it is. And in comes lithium, which really helps protect those engines.
Yeah, you really start to see how these dots connect when you look at how these pathways support each other. The PKC pathway, this is one of these kinase, these enzymes that transfer phosphate from one molecule to another. And these are really important pathways when you want to stimulate cell activity, cell growth, cell division. But if these pathways are overstimulated, you get that same hyperexcitatory effect. the cell's ability to adapt becomes compromised, mitochondrial activity, as you pointed out, John. So this has some inhibitory or downregulation of those effects. The same with this, the phosphoinositide pathway, this IP1. These are also, again, kinase-related cell signaling and regulatory pathways. These really complex regulatory enzymes that can totally change the ecosystem of that cell and the tissues that those cells compromise. And again, down regulation here has a more calming, inhibitory adaptation. This would almost be like the equivalent of cellular sleep, allowing those cells to regenerate, mitophagy, the recycling of cell components. You get out of this perpetual overdrive. And it also has that calming effect on dopamine. And we know that people with chronic stimulation of dopamine, maybe through addiction, maybe through certain behaviors, risk-taking behaviors that, like gambling's a good example of, you are just flogging your dopaminergic system. And over time, that the adaptation will be to lose your ability to make dopamine when you need it. You lose your ability to break it down when you need to be breaking it down. And I think when you look at all degenerative neurologic diseases and many mental health, behavioral health diseases, these are the mechanistic pathways that seem to underlie mood and cognition and the ability to cultivate more resilience and the ability to adapt. And so this is just a really beautiful overview of many of these mechanisms, right? So again, John, if this were a patentable, a molecule you could trademark, Big Pharma would be all over this. But that's not the case here. And again, this is just another graphic, and I apologize for those listening to this. All of these slides and these articles, open source articles, will be on our website for those who want to do a bit more of a deep dive. And the video will be on our website as well. But again, John, right, we know that all degenerative neurologic diseases, chronic stress, certainly the research that's been done in bipolar disease, that when you look at the brains of these individuals, you see immune stimulation, right? The microglia are the immune cells of the central nervous system. They're on overdrive. And you see this overproduction of these inflammatory mediators, interleukin-6 and TNF alpha, the sort of the usual suspects. You see this toll receptor activation, which is an immune system mechanism that ordinarily would allow you to recognize a foreign threat and deal with it. When these receptors are overactivated, you may be more sensitive to certain, your body may react to gluten. It may react to other things that it otherwise would have more tolerance to. And again, it's a good sort of sociologic metaphor. You see so little tolerance in our culture these days.
Yeah, right? For sure.
So you need these receptors to be balanced so that they know when to react and when to just observe and tolerate. We talked about the GSK activity and how these pro-inflammatory states, you see overactivation. And so lithium, as we've talked about, inhibits all of these processes. The GSK3 diminishes these inflammatory responses, will interfere with these tau and amyloid proteins, will enhance neuronal tissue to be more plastic, more adaptable. And in the absence of those adaptations, right, you'll see more depression, suicide behaviors,
Yeah.
cognitive impairment, which we might call moderate cognitive impairment or Alzheimer's or dementia.
Hmm.
So lithium has this host of beneficial effects on these pathways that are known to drive disease when they are not well regulated. It's a really nice slide, John. I like
No,
it.
that's incredible. I'm shows you how far-reaching it is, as well as the slide before that. Just looking at its role, the roles it plays in so many different facets of cellular physiology. This is a good
Yeah,
one. This is a
yeah.
good paper.
And,
Yeah.
this is a paper published a few years ago looking at the association between lithium use and the incidence of dementia. It was a retrospective study.
Yeah.
So you take a group of individuals, this was done in the UK, and most are on lithium in higher doses for treatment of bipolar disease or what psychiatrists might say mood stabilization. And then just looking over time at people taking lithium for those indications versus those that aren't taking it, is there a difference in the prevalence of dementia? And so the study basically, we understand dementia is the leading cause of death and
Hmm.
disability and continues to
Yeah.
go up dramatically in Western populations. We know that the modern medical approaches to slowing or reversing dementia have been woefully ineffective. There have been
Yeah.
very few, in my review of this, John, really innovative breakthroughs in this field. So lithium obviously has some intriguing possibility here. So they looked at 548 individuals that were exposed to lithium, and a large number who were not taking lithium. And over this 15 year period, and again, this is data from the UK. And then they looked at the incidence of dementia, including Alzheimer's disease, vascular dementia, which you typically
Yeah.
see with hypertension
Right.
and other vascular risk factors, and basically found that lithium was associated with a lower risk of
Hmm.
receiving a diagnosis of dementia of any kind, and both short and long term. This was interesting, John.
Yeah.
Exposures was associated with a decreased incidence. And again, this is retrospective correlation, but again, this is very intriguing in terms of trying to
Yeah.
extrapolate the mechanisms that we have looked at with sort of a population based shift in
Yeah.
prevalence incidence of dementias. And again, most of these individuals were taking lithium for bipolar disease,
Yeah.
which is known to be a risk factor for dementia.
Yeah.
Not
Well,
surprisingly.
exactly.
Uh,
Exactly. I think if anything, it strengthens the results here.
exactly.
Yeah.
We know that all of these, we might call them separate diseases, but depression frequently will coexist with
Yeah.
dementia. And so all of the pathways that we've looked at are shared by all these neurologic and behavioral health clinical diagnoses. And I think this might be the last slide,
I
John.
think so. Yeah. Yeah.
Looking at, and you brought this up earlier on, some of the initial observations of lithium and its brain protection looked at the relationship between trace lithium in drinking water and the rates of age-adjusted Alzheimer's disease mortality in Texas. The study was published in 2017, and this is a graphic which shows changes in age-related mortality for those getting more lithium, and these are blood levels, virtually no lithium, higher amounts of lithium, but these are nowhere near toxic levels,
No.
you see dramatic reductions in age-related Alzheimer's mortality, and these are statistically significant findings. Again, it's correlative, but intriguing nonetheless, right?
Yeah, incredible stuff, and it makes sense. I mean, if you find it, all of the things that went were that you presented there early on, Mark, from the one paper on physiological roles and requirements, you start to understand that it's just like vanadium and some of the other trace minerals. We should absolutely have more dietary guidelines or an RDA to set forth so that it does highlight its importance. I'm going to guess that for the average American, they only think that lithium is, more of a medication. They don't understand that it's an essential nutrient. Uh, Never mind the connection of that nutrient to different pathways in the brain. So I think it's an example, like I said at the beginning of this, of how little. I won't say like how little we know, but how little we appreciate the role of some of these molecules that might be found in certain plants as a phytonutrient, or in this case, a trace mineral, which, as we know, trace minerals tend to be a little bit more widely required in the body. I just think that there's a vast underappreciation for what the soil and the contents of soil has provided to human health and is still needed. And I just think that we have to get back to that, more ancestral appreciation for soil. And I think this is a great example of that.
Great summary to conclude on, John. For anyone who's interested, I do take lithium orotate, 5 milligrams a day. It costs pennies a
Point
day.
five, point five,
Five,
five
five
milligrams. Gotcha.
milligrams.
Okay.
And I see all potential upside, no significant downside. It's very affordable. I think we know a lot about safety profiles in lithium. It is one uh, mineral in pharmacologic doses for which there is a ton of data. These we're talking about very, very low toxicity risk. And so, yeah, I think we're going to see a lot more research here, John, but in the category of low-hanging fruit and more upside than downside, and something that won't give you sticker shock.
Right.
Uh, it, that's the personal assessment I've made right now, and we'll see. I'm also an ApoE carrier. I have the APO43. It's a heterozygous, which
Sure.
puts me at an increased risk of dementia, and so I'm have a bit more personal interest in anything I can do to maybe
Sure.
neutralize that risk. And we've talked about other. Uh, I eat a lot of red meat, John. I
Yeah.
go
Yeah.
back to a recent podcast as
Yeah.
we looked at unprocessed red meat and how that
Right.
seems to be associated with reductions. And so brain health is just such a huge issue. And when you bring mental health into that category of brain health, I mean, this is the bullseye and the target of
Yeah.
public health. And so I hopefully we'll see more research, but again, it won't be from big pharma.
No, and again, I just, in conclusion, I think that the perspective has been for the last 40 or 50 years, whether it's with respect to heart disease, whether it's now, in more recent years with respect to brain health, there's this perspective, and it's unfortunate that it is as pervasive as it is, that everything we experience in the way of diseases or disease processes is due to excess of whatever it is, XYZ. And don't get me wrong, there's strong evidence that excess sugar, excess refined carbohydrates are, they play pivotal roles in all of these disease processes. But the part that I feel is still missing, Mark, or has been lost for the last You could go back to the Hansel Keys, some of those messages, right? The part that's been lost is that so many of these diseases are not due to excesses, but deficiencies. And I think there's, again, there's massive amounts of evidence that when you get into Alzheimer's, you get into neurodegenerative diseases, you look at heart disease, a deficiency in any particular micronutrient sets you up for a disease process. And I think lithium's a great example of that, of how so many people are deficient. It's not even on their radar. It's not on their clinician's radar. It's nothing they ever read about. And so it's never highlighted in terms of its importance. But we have to be nourished first and foremost for the body to handle all of the different things that come at us, right? All of the different challenges that are going to be part of life, whether it's exercise, whether it's stress, whatever it is, the body needs. It needs nutrients. It needs a certain level or concentration, cellular concentration for everything. And here's an example of one where if you're deficient, you lose all of those different pathways or the possibilities for those to help stabilize, buffer us against stressors. So I always say nourishment, the concept of nourishment, Mark, has been lost. It's been completely lost.
Yeah.
And everything's fear-based. Nutrition is all fear-based now. It's like, don't eat this, don't eat that, don't eat this. And people aren't, people are afraid to eat eggs. People are afraid to eat the most nourishing foods, the red meat that you just brought up, and how much that contributes zinc and starts to create the balance between zinc and copper that a lot of people have lost, especially people that eat entirely plant-based diets. Most of those individuals have massive amounts of copper and very little zinc physiologically, and that sets us up for a host of problems. And I think lithium really falls in this category of we've lost our way with respect to the importance of nourishment. And that's like a foundation to all ancestral goals were to first be nourished. So I look at lithium as a prime example of that.
Great note to end on, John. Thank you for that.
Yeah, sure.
And we appreciate people tuning in to the Health Edge podcast. We are most grateful for you and appreciate your interest. And if this is content that you think might be helpful for those you love, for friends, maybe in the work that you do, please feel free to share. Nothing that John and I have on our site is copyright protected. We have this open source philosophy. It's just about sharing information that hopefully is reasonably objective and current. And so thank you. All of this can be found on the healthedgepodcast.com. And John, I hope to see you next week.
Absolutely. Absolutely,
the
Mark.
allows. Yeah.
I look forward to it.
All right, brother.
Hey, love you, man.
Peace
Thank
out.
you.
Love you too.